How do arrays work? It's a question not many people ask themselves, but why? Because they think they already know how they work. An array is just a variable that contains multiple values. Or is it? Well, you see, I asked myself that question and I found out that it's not true at all. So here I made a really simple C program that gets an array. And now let's try printing the whole array. So like instead of doing uh, instead of doing something like this, what if you do this? And it says that array is actually a pointer to an integer. That's weird. So what happens if we print it? So let's try running it. And it does seem to give an address, but what address is this? Let's try to dereference it. It gives 3. 3 is also the first element of the array. So what does this mean? Basically, what an array is just a pointer to the first element. And you might think, so what about the other elements? Well, when you create an array, it also preserves memory in the stack or memory, whatever that is, whatever. It preserves memory with those values. So this is also why when you, for example, initialize an array, you need to, you know, you need to define the size because the compiler, the program needs to know how much space it needs to take. And when you define it, since you're already giving it the values, it knows so many things it's gonna access, so gonna know the size. So let's try, for example, to accessing the second element without doing array second element. So let's try making a variable called the first item, and it's just gonna be array. And let's try jumping to the next. Let's try jumping to the next, or we can also do array plus 1, the next address. So now let's print this. Let's print this both, and let's compare them. So let's see what the output is. And we get 2 addresses, and this one seems to be the next address because it has a difference of 4. So what happens if we print the size of an integer? Maybe it printed 4 and the difference is 4, so it does seem like it actually is preserving memory. Let's try dereferencing them and see what actually happens when you dereference them. Okay, let's run it, and there we go. 3 and 7. First item is 3, second item is 7. So in this way, we just access the first and second element, and we can just do the same with, for example, the third element, So second item, just go to the next address and should print 12, and it does print 12. So now let's try writing it in an assembly to understand even more deeper how it works. So just for context, I am going to use nonce syntax. So let's print a simple hello world program as of now. So I included my own utils, which has things like printing, integer to string conversion and stuff like that. So let's include it. If you don't know, data stands for raw data, which stands for read only data, which is basically just data that you can't modify. You can just read from it, and it's perfect because we just want to print an hello world string. This 0 is a null terminator, and it's used for things like calculating a string's length, deciding when it ends. I'll make a video of it maybe sometimes. Okay, so now if you run this, it should print hello world. There it is. So now let's start making arrays. We just worked with an array. It's ironic. This assembly file uses an array. This hello world is an array. All these characters are an array. Hello world just prints this age. So if we, for example, print only one character, and we're gonna print the address of hello world, then it will print age. Why? Because hello world is an array, and an array points is a pointer to the first item, which in this case is age. But what if we are working with, for example, integers or keywords? How would you define an array? So it's really simple. You just gotta define a keyword with DQ, and then the items. So like, for example, I'm gonna copy over here. We have 3, 7, 12, 1. So I'm just gonna copy and paste it. And this is our array. So if we move into RCX, what is inside of array, and convert it to a string, and then print the string, what's gonna happen? It prints 3. Okay, so now let's do +1 to get the next address. What? What's this? Well, you see, when you do pointer arithmetics in C, the compiler already knows that we are talking about arrays. So it's just gonna add to the current address the size of the type name that we're talking about, like integer. An integer is 4 bytes, so it's going to add to this address 4. So in this case, our keyword is 64 bits or 8 bytes. So let's do +8, and it prints 7. The second item is 7. So now let's do 16, and it prints 12. 24, it should print 1. There it is. Getting a number wrong, like for example 25 instead of 24, just gives an address or something like that. I'm not that sure, to be honest. Like 18. Yeah. But to make it simple, I actually like to do this, for example. Alright? And you can ignore this part. You just need to worry about this part over here. Basically, the 1 is the index number, so it's basically just like doing array 0, 1, 2, 3, 4, and this just because of simple maths. Like, for example, you were doing 1 because 0 times 8 is gonna be 0, so it's gonna do the address of array 0, so it's not gonna change, it's gonna be 3. If it's gonna be 1, then it's gonna give 8, so +8 is gonna give 7, and so on. This is, and this should print 7. We can do this should print 3, then 12, and 1. And if you really want to, access to have the index list start from 1, so the first item is gonna be 1, the second is 2, and so on. You can really just do this, and you have to worry about this, and this part just ignore it. So the first item will be 1, then we have the second item, and so on. If you do 0, I'm not sure, it's like, yeah, it prints 0, and I'm not sure, like, the last exit code doesn't give, but it's also 0 normally, so I don't really understand. And let's say another thing, let's say that you're working with like D words which are 32 bits or 30 or 4 bytes. So let's access the first element, and it prints not bad. And it prints like an address or something like that. So why is that? It's really simple. We're basically putting a 32-bit value, since that's a D word is 32 bits. We are putting a 32-bit value into a 64-bit register. So we can just do expanded ACX, expanded CX, which is also 32 bits, and this should be normal. So yeah, let's say that you're working with a normal word, which is 60 bits or 2 bytes. You can simply just do CX and so on. So now you understand. Oh, and keep in mind that you need to change over here the size. Like D word is 60 bits or 2 bytes, so times 2, and it's gonna work. So this is how arrays work. I try to do it as simple as possible. We're trying to also go low level, writing even assembly code to make you understand. I hope that this tutorial was just, to help you out, or just, just a fun fact or something that it doesn't really help much. But see you guys in the next video, which is probably gonna be about null pointers. No, wait, null terminators. Oh, what was the name? Null, null, null stuff. Zero. Yes, yes, zero.